Hi, I want to talk a little bit about the honors project. I'm not going to give you too much help because it's an honors project and you're supposed to be able to figure this out on your own. Please read through this in its entirety and then reread it, but I'm going to just point out a couple of things. So first of all, we're going to just do analysis on three separate functions. You're going to do x squared, you're going to do either absolute value or square root, and then you're going to pick a function. One that's not listed there you might want to consider is 1 over x. But these are all possibilities. If you do something that's not listed here, how about checking with me first? But basically, for all of those, you can multiply it out something outside the function. You can multiply it times something inside the function. You can add something onto the x inside the function, or you can add something onto the function itself. And we've done a lot of this in class, so the x squared should hopefully be very easy. Now, one piece of formatting that's a little different here, I have my b on the same level as the x plus h. In class, we've typically done it over x plus h over b, and sometimes I'll call h and k, c and d. They're just placeholders for numbers that we're plugging in later. But if you want to do x plus h over b, because that's more familiar to you, that's fine. Just be consistent throughout the analysis, that you're always doing x plus h over b and not times. So you can choose to do it this way. The b will do something slightly different than what you're used to. And I think that's all I need to say about that. Oh, if you happen to go to another teacher and look at their grading rubric, so they actually will have it over B. They edited mine. But on creativity, they call this visual appeal, and that's really what I'm looking for. I don't know how creative you can be with this, but basically, that's kind of making it nice, putting it together in a nice format, things so forth like that. But the creativity is really showing a little bit more, maybe not quite what other people had done. I'll talk more about that later in class if you need me to. But largely you should be doing this out of class. Okay, so I'm not going to do one of your functions for you. I'm going to do a generic function, and you actually have seen this one before. This is the x squared minus 3, or a square inside of a absolute value, which makes this weird shape. But it's a function, and so that's the main thing we're concerned with. I'm going to show you what you might do. I'm in GeoGebra here. You could use Desmos. I like these better than the calculators because you can instantly see what happens as opposed to having to switch back and forth between screens. So I'd encourage you to use one of the online calculators to play around with this. And my expectation is that you will play around with this, as you'll just try some different things, and then from that you will narrow it down to a couple of representative graphs. So you might do 10 graphs, but then only pick 2, and then say, hey, this is where the A is, this is where the B is, this is where the H is, this is where the K is, and this is what those things are doing to this particular graph, both in general and specifically in the example that you have shown. All right, so I've got this function. Now I could retype this in with my with my number out front and my things added and subtracted on the inside, but I'm actually going to treat it like it's a function and just say, okay, whatever that function is, I'm going to add, multiply, and so forth. So what I'm going to do is exist. I've got a plan of what I want to try. These are the functions I'm going to try. I'm going to first just isolate the h and the k and throw those in there, and then I'm going to try some different things with a and b. You'll notice I'm not going to do it this way with the b underneath, but you could. Just remember to be consistent. And then also for the a and the b, remember to both look at and discuss what happens if that value is negative for a or b, and also what happens if that value is a fraction. What does it do in general? So that's in the rubric, so make sure you do it. And then finally, I'm going to do a complicated one. And of these, I might not even show the complicated one. I'm going to play around with this, and then from those, I will decide to pick a couple of those to show as a representative sample of my analysis to support what I say A, B, H, and K do to this stuff. All right, so first one, I'm going to do, I'm going to call it g of x. This may be hard with one hand. G of x. And that's going to equal, so I'm going to just take f of x, whatever my function is, and I'm going to just add 3 to it. Oops, plus 3. And I got to get the plus right. This is, it could take a while. I'm doing this one-handed and filming because my tripod's kind of shaky. Okay, and then immediately it pops this thing in there. So that's what the actual new graph, you can see it over here, looks like. But really, this is f of x plus 3. And it did what I kind of expected it to do. I'm going to call this my vertex. It basically shifted my vertex over by 3. Aha! That looks like, you know, and I could play around with that and make sure that happens all the time. But this should look familiar from class. And similarly, I could do another one and say, okay, let's make k of x equal to f of x plus 3 on the outside. And then you can notice that it actually shifts up here. Let me change this a little bit so you can see a little bit more. I'm going to drag it down so you can see a little bit more. Okay, and so there's k of x. It's right there. So as I do this, I'll change these numbers around and just start to develop a pattern if I don't know what it is already, which hopefully you do. And then I'm going to try some of the multiplication patterns. So I might do, and I can just do y. You don't have to use f of x. I like it because it, I think it labels it better when you use the function notation here. But so maybe I just double f of x. And you should have an idea of what this is about to do, hopefully, if it doesn't freeze up, which it just did. And it's spinning, 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 of course, during my video. There it goes. XX. Okay, let's try now. Check your input. Did not like that. Two times. Oops. F of x. Please check your input. Why is it not? Oh, it doesn't. Oh, it doesn't like it when I do this way. That's why I do it this way. So I guess I was wrong. I guess you have to do it that way. So let me give this GK. Let's make this P of x. Doesn't like when I mix y with function notation. Okay. You can type in y, but you have to type in the whole equation. And so let me turn these others off so I can see what this is. And that's the other nice feature about this. I can turn these on or off. I can leave them up there, but then go back and look at this. And so there is a version of putting a 2 out front. And then finally, I might do, let me just do one more and then I'm going to be done. So I'm going to call something r of x. And I'm going to do equal f. And I'm going to do a negative fraction, just to remind you that you're supposed to be looking into these kind of things. And you know, what does that negative fraction on the inside do to this thing? And maybe I can tell or maybe I can't. But now that I've done all these, and like I said, I'll do one more with kind of everything in there. So I'm going to call t of x equals 5f of 3x minus 1 plus 2. I also like using different numbers here, like the 5, 3, 1, and 2, because it makes it more apparent what numbers do what. So that's a nice trick to try. So I'm going to turn these others off. And so I've got some different things to show. And so what I might do if I was going to do this, once I'm happy with, I kind of understand what these things do, I might pick one or two of these. I'd probably definitely show the parent function if it's not obvious what the parent function is. And then I'd pick one or two of these and probably take screenshots of them. Maybe I'd put them on the same graph. Maybe I'd put them in separate places. I'd then probably label it and then specifically say, you know, in this case my A is 2 and the 2 does this, and my B is this and it does that, and my H and K are this, and you'll notice, you know, this point here corresponds to those numbers. So hopefully that gives you some insight of what you're supposed to be doing. And then once again, read the instructions, read them again. When you're done, read the rubric. And if you'll turn it in a week early, I'll even tell you if something's not right. In fact, that's what I'm going to tell you to do if you come and ask for help. I'm going to say, go try it, show me what you've got, and then I will tell you what's missing. Because that's as much instruction as I plan to give. Ciao.